So let's take a bit of a comparative look at some of the service meshes that are out there, as I like to call them, Schmesh comps. So these are the grouping of both open source offerings and commercial offerings that I've sort of focused on in this presentation to compare. And I'll be honest with you, I have now added 4 or 5 of these as I have done this service mesh presentation over the last 2 years, I think, as this has been developing. We're going to talk about Envoy, which is the foundation proxy for a lot of these implementations, and of course Istio, and the Linkerd and Linkerd 2 because they came out with a new version. I'll focus more on the Linkerd 2 as we go. There is a continuous mesh capability, and I'll give you some information about that. I spent a little bit of time with the Gray Matter folks. Gray Matter is actually a mesh of meshes, perhaps, and includes some additional features that may not be in some of the others. And then from a commercial standpoint, Consul, Aspen Mesh, which is a commercial implementation of Istio, Kong, which is a highly developed project that goes beyond the extents of Kubernetes into bunches of other container orchestration methodologies. Of course, AWS has their own. I won't talk very much about that because they stole it from Istio, but that's okay. Superglue, in the same way that Istio is a mesh of meshes and continuous mesh is a mesh of meshes, allows you to control more than one from a single pane of glass. And finally, just because I wanted to be fair to everyone, VMware's Tanzu implementation of Kubernetes contains a service mesh, but aha, it's founded on Istio as well. Okay, so those are the ones we're going to compare. And now let's break down the open source ones in those categories. The ops mesh. So this will give you a really good view of what a sidecar architecture looks like. It was originally a high-performance application service written in C++ by the people from Lyft. It used that proxied architecture and was developed against the software-oriented architectures of old. That's been around since I was playing in Dirt. And the two greatest features was, of course, giving observability and allowing you to debug what was going on between microservices so you could recover easily from things. And the gRPC bridge remote procedure calls allowed you to use Python as a client, which was a big advancement from how they used to do it in libraries. But the biggest thing about it was developed directly for the performance of a proxy service. And there's very few moving parts. You've got the main threads, you've got the worker threads, and you've got the file flusher that makes sure that anything that's unnecessary it throws out of RAM, since this sidecar methodology uses a little more memory than other methodologies. So this is Istio's implementation of that methodology. It's founded on Envoy as a proxy, but in the second iteration of development from Netflix, going from Helix and Ribbon, they decided the sidecar methodology would work out better, and they introduced circuit breaker technology, which allowed the application developer much more control. This one has more moving parts in it because it's doing more things. So the manager itself is the rules manager for policies and things that drive the Envoy proxy capabilities. The mixers allow for probes for the telemetry to be captured. And of course, authorization, Istio auth, allows in the control plane for service to service, TLS, and all of the encryption methodologies that keep things safe. The data plane is really thin. It's just a feature-rich Envoy proxy that they've sort of stripped everything else out that would have to handle anything like Policy Engine or any of those things. So that's the Istio sidecar architecture. Linkerd 1 it could have been done in either a node agent or a sidecar architecture. Most of the time, I guess people had used the sidecar architecture and so they decided to rewrite that portion of it, which ended up being the Linkerd 2 version. This is depicting the node agent side of this thing, which, as you can see, if the node 2 proxy goes, all of the application A, B, and C traffic that goes through it would stop processing from host 2. But it had a high degree of concurrency, and it could push things pretty fast, which is what really Linkerd, the initial iteration, was known for. Their sidecar implementation took what Istio had done with their mixer and control plane and sort of puts it on steroids. So you have a much higher level of control over various sections. And of course, it's gathering all of the various telemetries and everything else directly through the control plane, as opposed to having a mixer that you could plug and play additional items into. And then once again, the data plane has its own proxy sidecar, but instead of using Envoy, they have written their own. And as the folks from the Linkerd 2 group who I spoke with describe it, as opposed to Envoy, which is sort of using a Swiss army knife to do proxying, this is like using a needle, a specific pin prick to accomplish the proxy process, which makes it really fast.